Hi, I'm Christopher, a research software engineer with Research Software Workshops, and it's a very warm welcome to part 2 of Text and Sentiment Analysis in R. The material's at the webpage below, and if you navigate to the Tokenising section, you'll reach a page that looks something like this. Now, the first step to analysing text in R is to convert it into a form that will make it easier to process, and this means we need to tidy the text up and arrange it into a tidy tibble. Now, to do this, we're going to be using the tidy text library and of course packages from the tidyverse. So the first thing to do is to import these packages. So in my R Studio, I'm going to create a new R Markdown notebook. So we'll go basically new R notebook. And then I'm just going to get rid of everything down here because I don't need all of the default things. There we are. Let's minimize the console. And then if I save this by clicking the save icon, I can call this a file. I'm going to put it into my workshop directory just so we know that's here. So this is going to be called Tokenising. If I can type .rmarkdown notebook. There we are. So let's start by importing the tidyverse and also the tidy text package. So let's put in R block and then we'll do library tidyverse. And then also this tidy text package, which is what we're going to be using to perform the tokenization. Let's run that. Okay, they've both run, they've both connected, everything is fine. Okay, so next we need to have some text which we're going to analyze. And we're going to start by using the first few lines of Hamlet's famous soliloquy, to be or not to be. Now we're going to create this as a vector, with each element in the vector being just one line from this text. So I'm going to copy and paste this from the notes. You don't want to watch me type out all of the Hamlet soliloquy in one go. There you are. So that's created the actual text. You can see there we are. The text has popped up into our environment. So it's one line, one for each line of this poem. Now, our next step is to convert this vector into a tibble. Now we want this tibble to have two columns. The first column, which we'll call line, will hold the line number. Now there are 5 lines, so this is going to be a count from 1 to 5. The second column we want to be the actual text, so each line itself. Now we can do this, and I'm going to actually put this into the same R block here, by saying that we're going to say the text is going to be created from a tibble. Now as I said, line is going to be the line number, and that's just the numbers 1 to 5, so we can do 1:5 to create the numbers 1 to 5, and then the actual text column will be the text we've just loaded. And then if I print this to the screen, let's now run this. There we are, we can see we've got a line column 1 to 5 and then a text column with each of the lines of text one by one. Now we have the text into a tibble. We want to rearrange this tibble to make it tidy. Now you remember that tidy data from the last workshop is data where every variable has its own column, every observation has its own row, and each value must exist within its own cell. So, we're talking here about every observation having its own row. So what is the observation when we're talking about text? Well, in tidy text, an observation is called a token. A token is the smallest unit of text that you want to analyze. So for example, a token could be individual letters. So we could say that T would be a token, O would be a token, B would be a token, E would be a token, etc. Or we could be looking to analyze individual words. So 2 would be the first token, B would be the next token, or would be the next token, etc. Now, instead of analysing words, the tokens could be combinations of words, which are called engrams, which we'll come on to later in the workshop. Or they could be individual lines, so this whole line could be a token, the next line will be a token, or it could be paragraphs. So essentially you can see the choice of token really depends on what you want to analyse. The token is the smallest unit of text that you need for your analysis, so it's the atomic unit. Now it's up to you to decide what the appropriate token type is for your analysis. So for example, if we were counting the number of times each word appeared in the text, then the token would be the word. If we were analysing average line lengths, then the token would be the line. Now in this case, we want to count the number of times that each word appears. For this analysis, the token, and thus the observation, is a word. This means that each observation must have its own row, so each word must have its own row, and that means we need to transform the tibble so that we have one word per row. But what about the first rule of tidy data, that every variable has its own column? So what are the variables for this text? Well, there's actually two variables. One variable is the line number, so the line number on which the word will appear. And then the second variable is the actual token itself, so to, be, or, not, etc. So we're going to put the line number into a column called line, because each variable has its own column. And we're going to put the actual token, each word, into its own column called word. So this means we're going to be transforming our tibble so that we have two columns, line and word, and each word should be on a separate row. Now we could of course do this manually. We could split this line up by words and then sort of extend the tibble downwards to put each word on its own row. But fortunately, the tidy text library already provides a function to do this for us. The function is called unnest tokens. So we're going to use it now. So let's create a new R block. And we're going to create our tokens as a new tibble. It's going to come from the text tibble that we've had, and we're going to pass this through the unnest tokens function. Now, unnest tokens by default is going to tokenize into words. So all we need to do is basically provide the name of the column that we want to tokenize into. So we want the name of the column to be word, and then the name of the column, the name of the column that's actually going to be tokenized, which in this case is the text column. So if we run it that way, and then let's take a look at what tokens looks like. There we are. We can now see that this is basically broken out each line, and we now have each word is on its own row. So all of these are the words from line 1. And then as we go through here, all of the words from line 2, and then 3, and then 4, and then 5, etc. Now, as I said, by default, unnest tokens will tokenize by words. Now you can change the choice by passing different arguments, different options to this function, which we will do later in the workshop when we tokenize by n-grams. Now the first argument, which we put in here, word, as I said, is the name of the column in which we're going to place the tokens. So the tokens have now been placed into this word column because we named it word. Now the second argument is the name of the column which contains the text to tokenize. So you can see it's this text column in this tibble, which we have now tokenized into the word column. Now, one thing you should note is that unnest tokens has automatically lowercased all of the words. So you can see here the capital T for 2 has become a small case t. The other thing unnest tokens has done is it's removed the punctuation. So you can see we've lost the comma after B. And also after this B and that, we've lost this like double hyphen. And so it sort of cleans the text up a bit as well. So it's a little bit better than if we just wrote this function ourselves. So now that we have the text in a tidy format, it's now very easy to count the number of occurrences of each word. And we can do this using the same tools and techniques we've used in previous workshops. So we can use, say, for example, the count function, which comes from the tidyverses dplyr package. Now we're going to pass sort equals true to this, so then the resulting tibble is sorted with the most common words at the top. So let's do this. So let's pass the tokens through the count function, where we're going to be counting all of the occurrences in the word column. And as I said, we want to sort it so we can see the most common things coming at the top, most common words at the top. There we are. So we can see in this particular piece of text, the word to has appeared 4 times, the 3 times, and then everything else has appeared a smaller number. Now, so far, that's basically taken us all the way through this first part of the workshop. We're now going to look at the reading text from a file section of the workshop. Now, tidying the text makes all subsequent analysis much easier. Now, one of the issues we've had so far is that we've been typing the text manually into our R script, which is of course not that great, particularly when the text is large. So what we also need to be able to do is actually load text into R from external sources. Now fortunately, R comes with many functions which enable you to read text from files. The most useful one, in my opinion, is the readLines function. And the readLines function can read all of the lines from a file, from a text file, either if the file is local, so I could have put a local file here, so just the file path to a file on my own computer, but also it can read it from the web. So in this case, I've passed in the URL, and this URL contains the full text of Hamlet's soliloquy. So I'm going to copy and paste this and put this into my R script. And this is now going to read in the whole of Hamlet's soliloquy. And again, you can do that as this as well. And so what readLines will do is it will read that text file, and each line in the text file will be a different element in the vector. So it's returning a vector. Now that we have the vector, we'll do what we did before. We now want to convert this vector into a tibble. We want one column called line, which will have the line number, and this is going to run from 1 to the number of items in this vector, which is length lines. And then of course we want the actual text itself to be placed into a column called text. So let me do this now. So we'll call this tibble Hamlet, since it's Hamlet's soliloquy. And this is going to be a tibble where the first column is called line, and that will go from 1 to the number of items in our text, in our lines vector. And the text itself will just come straight from the lines vector itself. And let's just show this to the screen. There we are, we now have our tibble. Each line is in its own row in the column. We have a line column, which we've basically said the line number, and that's then all sorted out. Now that we have the data in the tibble, we can of course tokenize it again. We can tidy the text up. We can do things like counting the number of words. So let's do that again. So if I can type properly, here we are. Going in, so let's call this Hamlet tokens. So it's going to take the Hamlet tibble, and we'll pass this through that unnest tokens function, which comes from tidy text. And again, we're going to tokenize into a word column, and we're going to tokenize the text, which is in the text column. And then what I'm going to do is I'm going to do the counting, because it will be cleaned up at this point. So if we now basically pass this tokenized, cleaned sort of tidy tibble into the count function, so we're going to count everything in the word column, and then if we sort it, it will then show us the most common words in this particular soliloquy. There we are, so we can see the word the has appeared 21 times, of 15, that 7, and sleep 5, all the way through. Now, the analysis of the most common words is made a little bit difficult because the text contains lots of these short words, the, and, of, etc., which kind of get in the way. These kind of words form the scaffolding of sentences, but they don't necessarily contain meaning in and of themselves. They're kind of used to join words together. Now, these sort of joining words in the field of text analysis are often called stop words. And for many cases, you don't really need them to analyse text, and so it would be useful if we could remove them. Now, fortunately, the Tidy Text Library provides a dataset, a dictionary of all of the English stop words. Now, we can load that by typing data stop words. And if we just see what this stop words dictionary looks like, it's actually a tibble. And this is basically a collection of all the words in a column called word, which tidy text considered to be stop words. So words that don't really add meaning of themselves, they're just used to join things together. And there's quite a lot of them. Now we can remove these stop words from our Hamlet tokens tibble by performing what's called an anti-join between Hamlet tokens and stop words. An anti-join combines two tibbles where it will return only the rows in the first tibble which are not in the second tibble. Now we're going to use the anti-join function, which is part of dplyr. And so we can do this. Let's create a new R block here. So I'm going to call these the important Hamlet tokens, so the ones that don't include the stop words. And so we're going to have to pass the Hamlet tokens tibble through this anti-join function. And we're going to be anti-joining it with stop words. Now we can do this because we actually have the word column is the same name in both of them. And so we'll actually anti-join the word column. And then let's see what this gives us. Here we are. So it's now joined things together. You can actually see in the R console, when it's printed, it's saying it's joining by word because it goes, hey, you have a word column in both of these two tibbles, so that's the one we're going to do the join on. And then the result here is basically a tibble where we only have the lines, the rows from Hamlet tokens where the word was not in the word column of stop words. So it's effectively removed all of the stop words. So you can see they've all gone. Now that we've removed all of the stop words, we can now count these important words. And we can do that just as we did before by passing this through the count function. Okay, let's see what we've got here. There are sleep, bear, death, die, life. Now that we have, removed those kind of confusing, sort of get in the way sort of stop words, we can now see that the most common words within this particular poem, within this soliloquy, sleep, bear, death, die, life, they kind of give a good insight into the meaning behind this speech. Now, of course, we can pipe all of these things together into a single pipe. So I've kind of shown you what this was all sort of broken up. But if we put all of these steps into one, we had Hamlet, which was the original tibble containing the lines of text. We would want to tokenize it by word. And then we want to anti-join it with the stop words to remove all of the words that are uninteresting, that sort of don't add real meaning, they're just joining words. And then we want to finally count the entries in the word column, sorting them to find the most common words. So putting it all together into one go, there we are. This would be the analysis to find the most common, meaningful words in this particular block of text. So that's now taken us through all of this section. For the next part, we're now going to look at how we can download more interesting texts. Now, to perform text analysis, you're going to have to sort of analyze large amounts of text. And if you're just looking for some text to sort of practice on, the Gutenberg package provides access to the Project Gutenberg, and Project Gutenberg is basically a collection of all of the sort of books which are now no longer under copyright. So they're effectively free ebooks, loads and loads of them. And what the Gutenberg package does is it enables you to basically download those free ebooks into R, into a tibble. So we're going to load up first the Gutenberg package. Come through, there we are. So let's now load up the Gutenberg package. And then what we're going to, the book we're going to download is basically going to be The Adventures of Sherlock Holmes. Now, the Gutenberg ID of this book is 1661, which you can find by using the Gutenberg search engine. So again, if you want to find another book, just use the search engine and find the book that you wish. So I'm going to do Sherlock, and we're going to download this, and the function you need to use to download is called Gutenberg download. And then you just pass in the number of the book that you want to download. Now, it might take a little bit of time to download, but there we are. It is now downloaded, and you can see here is the text, The Adventures of Sherlock Holmes. And it's basically set up as a tibble. There are two columns. The first column is the Gutenberg ID, and the second column is the text, each line, one line per row. Now we can perform the same analysis as above, namely tokenizing by word, removing stop words, and then counting words to find the most common, by just passing this text through the same process as we did for Hamlet's soliloquy. So remember, we've now got Sherlock is our tibble that contains each line. We're going to pass this through first unnest tokens to tokenize it by word, and the column is text, so we can just use the same text column, which is fine. Then we want to anti-join with the stop words because we're not that interested in the stop words. And now we can then count the entries of the word column, and we'll sort equals true because we want to find the most common ones. Okay, so let's see what we get from doing this. Okay, so we can see Holmes appears 462 times. It's probably not surprising for a Sherlock Holmes book. And then we have time, door, matter, house, hand, knighthood, found, day. So you can sort of see there are Sherlock 97 times, Street 83, Watson 81. So you're kind of picking out some of the more common things. Now this is of course shown all of the words, and there's a lot of words in this particular book. Because there's so many words when you're doing text analysis, you really don't want to overload the computer with sort of the uncommon things. You probably do want to be using the filter function, and the filter function from dplyr can be used to filter out elements based on a condition. Now in this case, n is the count, and if we want to say only show us the words that have appeared more than 75 times, then what I could do is I could add an extra line section here and actually say let's filter this where the count n is more than 75. And now this is a much smaller tibble, which will be much easier to work with. So we can see light is the last word that appeared with 76 times. That's much easier to work with. Now reading the lines like this and looking at the numbers, we as humans are very poor at sort of looking at tables of numbers. And so it might be useful to be able to actually plot this as a bar graph. Now we can do this using Ggplot, just as we would do plotting any other graph. Now, to be able to plot the data, we need to make sure that the text itself is a factor rather than just a piece of text. So in this case, each of these entries in Word, they are just strings, they're bits of text. But if we want to plot this as a bar graph and have each word be sort of one column in the bar graph, they need to be turned into factors. Now we can turn a piece of text into a factor by using the mutate function and using the reorder function, which is in core R. The way we do this, let's put this in here, is we're going to basically take this counts tibble, because we named it, we have to save it first actually something. So let's save this as counts. And then we'll take that counts tibble, and we will mutate it. So we're going to mutate it by basically changing word into a factor, which can be created by using the reorder function. And using the reorder function, working where n is the column, basically the number of times the word has appeared, we'll then make sure that we've sorted the factors. If we now look at this when we've performed that function, what you can now see is that word is now a factor. And again, it's now in order as well. It was sorted as before, but it's definitely now in order. And so the first factor is Holmes, the second factor is time, the third factor is door, etc. Now that we have factorized, we have converted those bits of text, those words into factors, we can now render it as a bar graph using Ggplot. So we're going to pass the counts tibble through Ggplot. Now in this case, the aesthetic is going to be the number of occurrences on the x-axis and the word itself on the y-axis. So we're going to put the number of occurrences, which is the n column, on the x-axis, and the factor, the actual word itself, on the y-axis. Now what we're going to be plotting is a column graph, a bar graph, so that's going to be geom_col. And then finally, we don't really want to see sort of the labels on the y-axis. We just want to see the factor itself. And so we can say labs y equals null, which will then basically turn off those labels. There we are. So now we've plotted it, we can see homes is definitely the most common word within this text. And then it's much easier to now see sort of the spread all the way through to light, which is the one that appeared 76 times. Okay, so that's now taken us through all of this block of text in the workshop. It's now brought us down to the exercise at the bottom. What I'd like you to do in this exercise is I'd like you to go onto Project Gutenberg and find a book that you want to analyse. I want you to download the book and I want you to create a graph of the most common words, ignoring stop words, pretty much the same as we've done for this Adventures of Sherlock Holmes. I'm going to give you a little bit of time to sort of have a go at this and basically press pause. And when you come back from pause, I will show you the answer. Okay, you've now come back from pause. So I'm going to show you the answer now. So I'm going to choose to do the Hound of the Baskervilles. So what I need to do is I need to go onto the search page. And if I type in here, Hound of the Baskervilles, there we are, Hound of the Baskervilles has popped up. And we can see the Hound of the Baskervilles, what is its ID number? There we are, the ebook number is 2852. So that's the number I'm going to have to put into Gutenberg download to be able to download it. So I'm going to sort of do this at this bottom part of the page. So remember, you will have to have imported the Tidyverse, Tidytext and Gutenberg packages. But once you have, you can then basically say, okay, Hound is Gutenberg download. And in this case, I'm bringing in the book 2852. Next, I'm going to have to tidy the text up by tokenizing it. So I'm going to pass this through unnest tokens. And I'm going to tokenize the word column, tokenize into the word column, and I'm tokenizing the text column. Finally, I'm going to anti-join the stop words. And again, you must remember to have loaded the stop words up as we did earlier on in this workshop. Now that we've done that, we can now count the number of words. So we're going to put this into a counts tibble. And so this is basically going to take the Hound tibble. We're going to count the word column, again sorting to see so we can find the most common ones. And then we're going to filter. In this case, we'll filter again, I think on n equals 75, n is more than 75. So just the most common words. Again, for your book, you might need to use a different value here. Okay, now we've built this, we now need to mutate this tibble so that the words, the text, is turned into a factor. So basically we're going to pass counts through the mutate function, where we're going to change the word from being a piece of text, and we'll use the reorder function, which will convert it into a factor. And then finally we just need to graph this. So we'll do counts, put through Ggplot, where the aesthetic will be that we're going to place the number of occurrences of the word on the x-axis, the word itself on the y-axis, and this is going to be a column graph, a bar graph, where we don't want to show the name of the column on the y-axis, because we can see it's already the word. Okay, that's all together. Let's run this and see if this works. There we are. So in this case, we can see that Sir was the most common word in Hound of the Baskervilles, followed by Holmes, Moore, Henry, Watson, Baskerville, Dr. Watson, Mortimer, Time and Stapleton. Okay, so that's now brought us to the end of this workshop, or the end of this part of this workshop. I hope this was useful. If it was, I look forward to seeing you in the next part of the workshop, and I look forward to seeing you there.